So sine theta is given by y values on the unit circle. So let's just revise that real quick. If you remember, if I've got a unit circle and I create a right angle triangle like that, where that is theta there, then what's the bottom side? What length is that? Oh, sorry, no, I haven't. You can't answer that yet because I have to define this as the point xy. So now, who can tell me what that green side is? What length is that? X. Who can tell me what that vertical side is? Good. What length is the hypotenuse? 1, because it's a unit circle. Everyone with me? So the idea is sine theta on that triangle is opposite, which is y, over hypotenuse, which is 1. So y equals sine theta. So that's what they were saying at the top. So now, but on a unit circle, the y values go from positive 1 down to negative 1. So sine theta will be between 1 and negative 1 as well. Similarly, does that make sense? Okay. Now, if you in your calculator put, here's a graph of it, but I'm just going to put out there. Using the unit circle and the fact that sine is always the y value. What is sine of 0? Yes, the y value at that point is 0. So if I were graphing y equals sine theta, try that again, y equals sine x. X is down here, so the angle x is on the x-axis. Y is the value you get, sine of x. So sine of 0 must be 0. Is that okay? Now I'm going to go all the way around to pi on 2. What's the y value at that point? Oh, 90 I should say. 1. So sine of 90 is 1. That's why at 90 on the x-axis, I'm at 1 up here. Does that make sense? Now if we keep going, what's sine of 180? Nope. 0. The y value at that point is 0. So I come back down to 0. Okay? Let's keep going. 270 is down here. What's the y value of that point? Negative 1, so I'm down here now. Rhiannon, do you have a question?
Oh no, I was about to say negative 0 before.
That's okay.
It's not a thing.
2 pi or 360 is back here. What's the y value there? Again, 0. Then what happens if I keep going around? The y values repeat. So what we've just drawn, which is up to like this, up to 360, that just repeats. It'll just keep repeating like that. The y values just keep repeating because the unit circle, we just keep going around the same circle. What is the period of the sine function? In other words, first of all, is this periodic?
Yes.
What does periodic mean again? It repeats in a horizontal way, so yes. What is the period? So in other words, girls, let me just get a red. When does this 0 happen again that then goes upwards? At 360, we're 0 and going upwards. So that point repeats 360 degrees later. Or if we're in radians, 2 pi radians later. So the period is 360 degrees or 2 pi radians. Is everyone okay? All right. Now, what is the amplitude? In other words, what is the vertical stretch? If you remember, girls, amplitude goes from the principal axis, which in this case is the x-axis. So, girls, do you agree that the x-axis there is the middle of the function? Beautiful. It splits the thing in half, kind of. So, what is the length from there to the maximum? So that length there, vertical. That's a length of 1. So the amplitude is 1 because of that length from the principal axis to the maximum point would be 1, or even here, the principal axis to the minimum is 1. How's everyone going? Amplitude is 1. Okay, now using technology, we will graph the following functions. For each, state the period and amplitude. Okay, so the amplitude, which we'll call capital A. Capital A is 1. The period, usually for y equals sine x, this is the period, 2 pi. But y equals sine 2x, we just got pi. And 6x, we got pi on 3. And 0.5x, or in other words, x on 2, we got 4 pi. Take a moment, discuss it with your friends. Or can you tell me what sine of, I'm going to make up something, 4x, the period would be? Take a moment, discuss it with your friends. These values for A, B, and C were found using Desmos, graphing the functions on Desmos, and we could see where it repeated and what the amplitude was. So if you graph those functions on Desmos, you'll see what the period is. And so now we're finding a rule. So the period was pi on 2 for sine 4x. I'm going to move on, but I'm not that surprised that people are getting lost because they're not paying attention. So, for normal sine x, it's 2 pi. But what happened for A? We have 2x. So what do you do to find a period of pi? Divide 2 pi by 2. So whatever that number is in front of x, you divide 2 pi by. So 2 pi, the usual period, which is up here, divided by that 2 in front of the x, does in fact equal pi. Let's look at the next one. We got 6x, so what are we going to do here? 2 pi divided by 6. Oh, look at that. It is pi on 3. Next one, we had 0.5, or a half. What's 2 pi divided by a half? That is 4 pi, because you end up timesing by 2. So it makes sense that if y equals sine 4x, the period will be 2 pi on 4. And simplify that, you get pi on 2. So that's the rule. So girls, on the next line, can you tell me the period of all of these? This one doesn't have any number in front of x, so it'll just be 2 pi. This one doesn't have any number in front of x, so it's just...
So does the 5 and the not...
We'll get there. I'm not focusing on them yet. This one has a 2 in front of x, so what do I do?
It's just pi.
2 pi over 2, which is just pi. Now, the number in front of sine in all these, we don't know what that does yet. Let's have a look. Let's go back to Desmos, okay? So I'm going to make it maybe, actually no, wait. So by graphing this on Desmos, y equals sine 2x, we realize the amplitude is now 2. The function has been stretched out and gone up to 2 and negative 2. What do you think's going to happen for E?
5.
It's going to be 5. Let's just double check. We were right, the amplitude is 5. And now for F. 4. So with F, we're both getting a vertical stretch with an amplitude of 4, but also, what's that 2x doing? Is it squishing or stretching horizontally? Squishing. Okay? Because the periods become pi, not 2 pi. Okay? To summarize all that, if you've got a number A here in front of the sign, the amplitude is that value of A. I've got absolute value signs there because if you add negative 4, the amplitude would still be 4. It would just be flipped. We'll look at those later when we graph them. The number here divides 2 pi to get the period. It isn't the period, it's the number you divide 2 pi by to get the period. Use technology and graph the following functions and describe these transformations. Now, girls, you should actually know this based on your other functions work. Would anyone like to guess, just guess, what happens in A if I add 2 to x inside the brackets? That's important. Left, yes, it moves in the -2 direction. So let's write that down. It shifts, or translate is probably the better word, left by 2. And maybe you can check these using technology. B, would anyone like to suggest what the transformation is, Roxy? Right by 1. So it translates, I could use the word translates. Right, by 1. Now, remember, so because it's affecting x and it's inside the brackets, we go the opposite direction and we're going horizontally along the x-axis. Is everyone okay? Now, notice that the +3 is not inside brackets. It's sine x, and then whatever the result is, you add 3. Would anyone like to suggest what the translation is? Up by 3. So, because girls, this +3, it's outside of the function. So it's affecting the y value. So we shift up by 3. What about D?
Down by 4.
Beautiful. Shift down by 4. E shifts left by 1, and I guess you could say 1 unit, and up by 2 units.
Do you always have to say unit?
I probably should. I doubt you'd be marked down though. Okay, general rules. Basically, this is a summary. What would, can you just first describe to me what this would look like? Period equals 2 pi on 3. Does everyone agree?
Yes.
Beautiful. Keep going if you like.
And then the amplitude would be 5.
Beautiful. Amplitude. Amp is 5 and?
And then it'd be shifted up 1.
Beautiful. Shift up 1. Now, how do we draw something like that? Is everyone happy with all that?
Yes.
Okay, now, how do we draw something like that? Can I just show you? So, girls, if I just was told to graph and they didn't give me any boundaries or anything, I would start at 0 and go all the way up to 2 pi. Okay? Then, girls, if my period is 2 pi on 3, so our usual first point is pi on 2. What's pi on 2 divided by 3? See how I divided the period by 3? I'm now going to divide everything by 3. So what's pi on 2 divided by 3? Thank you, pi on 6. Then the next important point is pi. Pi divided by 3, oh, that's just pi on 3. Then the next important point is 3 pi on 2. What's that divided by 3? Pi on 2.
Oh, pi on 2.
The next important point is 2 pi. What's that divided by 3? 2 pi on 3. Okay, I'm going to stop there actually. We're not going to worry about 2 pi. We're just going to keep it simple and stop there. So I divided all my usual points that I like by 3. Is everyone okay? So now, and what's my amplitude again? 5, but I also shift 1. So usually it would be at 5 and -5, but then when I shift up 1, what'll it be between?
6 and -4.
Very good, 6 and -4. Is that all making sense so far? I know it's complicated, don't worry. One thing at a time. Now, girls, let's think about 0 now. We're starting here. We're starting at 0. Let's think about that. That'll be sine of 0 times 5 plus 1. What's sine of 0? Usually, what's sine of 0? 0. It is 0. Times 5? 0. Plus 1? 1. So I actually get shifted up to 1. Does that make sense? Okay. Now, if you put pi on 6 in here, what's 3 times pi on 6? So y will be 5 sine 3 times pi on 6 plus 1. What's 3 times pi on 6? Pi on 2. What's sine of pi on 2? Unit circle, it's 90 degrees, so it's 1. So 5 times 1 plus 1 is 6. This is where it hits the top. Now, girls, we know what sine looks like. What do you think it's going to do here? It's going to keep going up. Tell me that. No, it's going to come back down. Where's it going to hit? Back on 1, because you know the shape. What do you think it's going to do here? Down to -4. And if you subbed it into the function, you would get it. What do you think it's going to do next? Up to 1. And keep repeating. And keep repeating.